For decades, NASA has searched the red planet for one answer. Are we alone? Now, after years of silence, something shocking has been found. Tiny dark spots buried deep inside Martian rocks, rich in carbon, iron, and phosphorus, the same ingredients that started life on Earth. Some scientists say it's nothing. Others say it's the closest thing to alien life we've ever seen. But here's the twist. We've been fooled before. False alarms, broken hopes, and billion-dollar mistakes. So why are experts calling this one different? Because this time, the evidence isn't hiding in theories or blurry photos. It's locked inside Mars itself, waiting to be brought back to Earth. When NASA's Perseverance rover, or Percy, as scientists like to call it, landed in Jezero crater back in 2021, the goal was simple but ambitious: find signs of ancient life. Jezero wasn't just any crater. Billions of years ago, it was a lake with flowing rivers feeding into it, a place where life could have thrived if it ever existed on Mars. For years, Percy drilled, sampled, and scanned the dusty red rocks. And then, it happened. Inside a cluster of oddly patterned stones, scientists noticed something strange. Tiny, dark specks, scattered like freckles across the rock's surface. They called them leopard spots. At first, they looked like nothing special, just minerals, maybe rust. But under the rover's laser spectrometer, the truth started to emerge. Those little spots were loaded with carbon, iron, and phosphorus, the same building blocks of life found in ancient fossils on Earth. And that wasn't the weirdest part. The chemical arrangement didn't match what you'd expect from a random rock. It looked organized, almost biological. NASA's scientists couldn't believe it. Some were cautious, others excited, but everyone agreed on one thing: Mars was hiding a secret that demanded answers. But what kind of process could create these patterns, if not life itself? That question sent shockwaves through the scientific community, and the next discovery would only make things stranger. Back on Earth, the data from Perseverance left scientists stunned. They'd seen something eerily familiar, something that shouldn't exist on a lifeless planet. Those strange leopard spots on Mars looked almost identical to minerals we find in one specific place on Earth: the bottom of the ocean, near volcanic vents where sunlight never reaches. Down there, life survives not on light but on chemistry. Tiny microbes feed on iron, sulfur, and carbon, creating the same kind of mineral traces Percy found on Mars. So when NASA scientists compared the Martian readings to samples from Earth, the resemblance was shocking. The chemical fingerprints matched. If this were on Earth, no one would even question it. They'd call it life, ancient, microbial, but unmistakably alive. But on Mars, that changes everything. Some experts began whispering that this could be the first biological evidence beyond Earth. Others warned against getting too excited, reminding everyone how many times NASA had been burned before. Still, one undeniable truth began to spread. Whatever created these formations wasn't random. It followed patterns, complex, deliberate, and intelligent in their chemistry. And as the data kept coming in, one chilling question echoed through every lab. If this isn't life, then what else could it be? Not everyone was convinced. In fact, the moment whispers of life on Mars reached the public, a wave of skepticism hit NASA like a storm. Scientists who had been through past discoveries knew how dangerous hope could be. They'd seen it before, strange data that looked alive, until it wasn't. So the skeptics went to work. First theory: maybe the spots were created by volcanic heat. After all, Mars is full of ancient lava fields. But that didn't fit. The rocks in Jezero showed no trace of melting or heat exposure. Second theory: maybe it was acid chemical reactions in toxic water carving weird shapes. But Percy's instruments found the opposite. The rocks contained olivine, a mineral that breaks down in acid. If olivine survived, the environment couldn't have been acidic. Third theory, maybe it was just rust, iron oxidizing over millions of years. But the structures were too precise, too patterned.
Rust spreads randomly.
These didn't. One by one, every natural explanation started to crumble, until even the skeptics had to admit, whatever caused these chemical signatures, it wasn't something we fully understood. And that's when the story took a darker turn, because the last time scientists thought they found life on Mars, it ended in disaster. This isn't the first time NASA thought it had found life on Mars. In fact, history is full of false hopes and painful lessons. Back in 1976, the Viking landers ran the first biology experiments on the red planet. The results? Gas bursts that looked exactly like microbial metabolism. NASA celebrated briefly. Then, further tests showed it wasn't biology at all, just a chemical reaction between the soil and a cleaning fluid inside the instruments. A billion-dollar heartbreak. Then came 1996. A meteorite called ALH 84001 was found in Antarctica, believed to be a piece of Mars itself. Inside were tiny structures that looked like fossilized bacteria. President Clinton even went on live TV, saying this could be proof of life beyond Earth. But once again, science crushed the dream. Those fossils turned out to be non-living minerals shaped by geological processes. Nothing alive, nothing Martian. 2 discoveries, 2 heartbreaks, and decades of silence followed. So when Perseverance sent back its new data, no one wanted to say the word life. Not yet, not again. But behind closed doors, something was different this time. The data wasn't just weird, it was consistent, repeatable, and chemical in a way Mars had never shown before. And when scientists realized what that meant, they started planning for something much bigger. After decades of searching, NASA finally had something it couldn't explain away. But there was one problem. The only way to know for sure was to bring a piece of Mars back home. That's where the next chapter of the mission begins. Perseverance had already done its job. It drilled, collected, and sealed rock cores inside small titanium tubes, each one a potential time capsule of ancient life. One sample stood out, Sapphire Canyon, a dark, mineral-rich core pulled straight from the area with those mysterious leopard spots. The plan was ambitious, maybe even insane. NASA and the European Space Agency teamed up to launch a mission called the Mars Sample Return. 3 spacecraft, 2 planets, 1 impossible goal: bring those samples back to Earth safely. The idea was simple in theory but terrifying in practice. A lander would grab the tubes, launch them into Mars orbit, and a second spacecraft would catch them mid-space before flying home. But space has a way of laughing at simple. Budgets started to explode. Timelines stretched from 2030 to 2040, maybe even longer. And every delay meant one thing: the proof of life, if it's there, stays locked inside those metal tubes, sitting quietly on a dead planet, waiting for someone to bring them back. When, or if, those samples finally reach Earth, the real test begins. Because finding life on Mars isn't about what you see. It's about what you measure. NASA already has a roadmap for this moment, something called the Confidence of Life Detection Scale. It's a 7-step ladder, where level 1 means we found something weird, and level 7 means we have proof of life, no doubt left. Right now, Mars sits around level 3. That means there's evidence, chemical, structural, and consistent, but nothing that screams biology yet. To climb that ladder, scientists will look for 2 main fingerprints of life. First, chirality. Almost every molecule made by living things has a handedness, a preference for one direction over another. Nature doesn't do that on its own. If Mars samples show that same bias, it's a biological red flag. Second, carbon isotopes. Living organisms use lighter versions of carbon when they grow and metabolize. If the Mars samples show that same isotope pattern, it would mean even something microscopic, once lived there. To do this, NASA's labs will use the same techniques used to confirm ancient fossils on Earth. Atomic-level scans so precise they can read the history of a single grain of dust. And if even one test crosses that line, from chemical to biological, the world will never look at Mars the same way again. But that's just the science. What comes next might be far bigger than any experiment. If those tiny Martian rocks really hold proof of life, it would mean something far bigger than just microbes in the dirt. It would mean that life, the spark we thought was rare, fragile, and miraculous, might actually be common. For years, scientists believed Mars was too cold, too dry, too dead. But the discovery in Jezero crater would rewrite that story. It would mean that billions of years ago, two planets, Earth and Mars, might have been alive at the same time. And if life could appear twice in one small corner of our solar system, then how many other worlds could be breathing right now? There's a theory called panspermia, the idea that life doesn't start on one planet, but travels between them, hitchhiking on asteroids or dust. If that's true, then maybe we didn't find Martian life. Maybe we're the ones who came from Mars. Think about that for a second. Every cell in your body, every thought in your head, could be carrying a story that began on another world. And that's what makes this discovery so powerful. It's not just about science, it's about identity. Because if life exists elsewhere, then we're not a cosmic accident. We're part of something much bigger, a living universe that's been trying to find itself for billions of years. But the story doesn't end there, because what NASA found next changed everything. In science, there's a rule called the 0-1 infinity principle. Either life exists nowhere, it exists once, or it exists everywhere. For centuries, humanity assumed we were the one, a miracle, a single spark in a silent universe. But if Mars truly held life, even something microscopic, long extinct, then we were never the only ones. And that means life doesn't just happen once. It happens whenever it can. That realization changes everything. Because if the universe creates life so easily, then it's probably filled with worlds just like ours. Some just beginning, others long gone. Maybe somewhere out there, another species is looking up at their sky, wondering if they are alone, just like we did.